Today, we're going to be talking about the concept of slope. So, we're going to start by looking at the definition of slope. So, the definition of slope is a number that describes both the direction and the steepness of the line, or a line. So, first, I want to look at the direction. What is the direction of a line? Like, how does that affect the slope? So, I have a nice analogy here. Pretend this is your house. This is where you live at this house. And school is right here. And this is where you go to school. So, to get to school in the morning, you have to walk down a big hill. What direction are you walking in? You're walking in a downward direction, correct? So this would be a downward slope. Now, pretend you move houses. Now you move over to a house that's down here. And now your school is up here. So every day you have to walk up this big hill. Well, this slope would be in an upward direction. You can also annotate this as negative and positive. So, one important thing to realize is that whenever you're looking at a slope, whether it be of a line on a graph, you always look from left to right. The way I read this and the way I read this slope was going from left to right. So that is how you determine the direction of a line. Next, we want to look at the steepness. So, the steepness depends on how rapidly y is changing. So, if we have a line like this, as x increases, as we look at this from left to right, as x increases, the y variable only increases by a little. See right here? It's only increasing by a small amount. But if we had a line that looked more like this, as we move from left to right, the y values, they're increasing much rapidly. So, this one would have a greater steepness. This one would be less steep. So that's how you determine the steepness of a line. So now we know both the direction and the steepness. Let's talk about this equation. Y equals mx plus b. So this is the equation for a linear function. And then m stands for our slope. This can also be written delta y over delta x, which stands for the change in y over the change in x, which can also be written as y2 minus y1 over x2 minus x1. B is our y-intercept. When we're given a linear function and we're asked to put it in this form, we're going to have to solve and find the slope and the y-intercept. We plug them in, and there's our linear function. So let's have an example with this finding the slope. So if I give you 2 points, point A, point B. A will be, let's do 2, 1. And B is -3, -1. What is the slope? So, we know m is equal to the slope. So, m equals, we use this right here, the change in y over the change in x, and we plug it in. So, let's label this x1, y1, x2, y2, and solve. There it is. So now we solved and we found that m, or our slope, is equal to 2/5. So example 1 is asking us to find the equation of the linear function whose y-intercept is at y equals 1. So we'll write that as 0, 1. And then has a point at negative 1, 3. Label that. So now we're going to label this as point 2 and point 1. So now we're trying to find the form y equals mx plus b, because that is the form for a linear function. This is a linear function. We can see it's a linear function. We connect these two dots and it will show us where the line goes. And this line goes up. So now we just need to find m and b. We know b because they give us b. The y-intercept is 1. So b equals 1. Now m, we use difference in y's and the difference in x. Now we can use our points. M is equal to negative 2. So now that's our slope. That's our y-intercept. We just plug them in. And that is the equation for the linear function whose y-intercept is 1 and has the point negative 1, 3. Let's do another example. So the first thing we should do here is graph it. They give us 2 points. So now let's put these on a graph and visually see where our line is. Alright, so now let's plug in our points. We have 0, 8, which is right here, and 0, negative 2, which is right here. So when we put this line on, we can see that this is simply a vertical line. So, is there a slope? Can a vertical line have a slope? Well, let's see. Let's plug it into our equation for slope. We know that m equals the change in y over the change in x, or y2 minus y1 over x2 minus x1. This is the same as this. The change in y is y2 minus y1, and the change in x is x2 minus x1. So let's plug in our values. Let's do this as x1, y1, and x2, y2. Plug in this. Negative 2 minus 8 over 0 minus 0. This gives us negative 10 over 0. Now, as you should know, we cannot divide by a 0. You cannot have a 0 in the denominator. Therefore, this right here, our slope, equal to this, means it's undefined. We cannot define this slope because there is a 0 in the denominator. Therefore, we say there is no slope. No slope. So since there is no slope, we can look at this. And the equation for this line would just be this. X equals 0. Because this function is just a line when x equals 0. Now let's try another very similar one. What if you had points 2, 0 and 7, 0? So let's try plugging these into our equation for slope. Which would give us 0 over 5, which is equal to 0. Now, since the 0 is in the numerator and not the denominator, we know that this is equal to 0, which is equal to our slope. So this one, we say has a slope of 0. So m equals 0, or just 0. So this one has no slope because it is undefined with the 0 in the denominator. But this one has 0 slope because the 0 is in the numerator. Therefore, when you divide 0 by 5, you get 0, so it has 0 slope. There is a big difference between these two right here. So the function of this one, if you were looking at this on a graph, it would just be a line right here along the x-axis would be y is equal to 0.